In this video, we are going to study about the distribution of charges in a conductor, action of points are corona discharge, lightning arrestor or lightning conductor, and also about Van de Graaff generator. Now let us study about the distribution of charges in a conductor and action at points. The distribution of charges in a conductor. Let us consider two conducting spheres A and B of radii R1 and R2 respectively, which are connected to each other by a thin conducting wire as shown in this figure. The distance between the spheres is much greater than the radii of the spheres. So if a charge q is introduced into any one of the spheres, this charge q is redistributed into both the spheres such that the electrostatic potential is the same in both the spheres. They are now uniformly charged and attain electrostatic equilibrium. Let Q1 be the charge residing on the surface of sphere A and Q2 is the charge residing on the surface of sphere B such that Q is equal to Q1 plus Q2. The charges are distributed only on the surface and there is no net charge inside the conductor. The electrostatic potential at the surface of the sphere A is given by this expression VA equal to 1 by 4 pi epsilon Q1 by R1, and the electrostatic potential at the surface of the sphere B is given by this expression VB equal to 1 by 4 pi epsilon Q2 by R2. The surface of a conductor is an equipotential surface. Since the spheres are connected by the conducting wire, the surfaces of both the spheres together form an equipotential surface. So this implies that VA is equal to VB, Q1 by R1 is equal to Q2 by R2. Let the charge density on the surface of the sphere A be sigma 1 and that on the surface of the sphere B is sigma 2. This implies that Q1 is equal to 4 pi R1 square sigma 1 and for Q2 it's 4 pi R2 square sigma 2. Now substituting these values in the equation on point 1 and 2, we will get sigma 1 R1 is equal to sigma 2 R2, from which we can conclude that sigma R is always a constant. Thus the surface charge density sigma is inversely proportional to the radius of the sphere. For a smaller radius, the charge density will be larger and vice versa. So these are the examples given on this basis, and next we are going to study about the action of points or corona discharge. For this, let us consider a charged conductor of irregular shape as shown in this 1.61a, like this. And we know that smaller the radius of curvature, the larger is the charge density. So the end of the conductor which has larger curvature, that means smaller radius, will have a large charge accumulation as shown here in this 1.61b. Here, there will be a large amount of charge present here. As a result, the electric field near this edge is very high and it ionizes the surrounding air. The positive ions are repelled at the sharp edge and negative ions are attracted towards the sharper edge. That will reduce the total charge of the conductor near the sharp edge. This is called action of points or corona discharge. So based upon this, let us study about a lightning arrestor or lightning conductor. So what is a lightning conductor? It is a device used to protect tall buildings from lightning strikes. It works on the principle of action at points or corona discharge. So the device will consist of a long thick copper rod passing from the top of the building to the ground. The upper end of the rod has a sharp spike or sharp needle as shown in these diagrams A and B. The lower end of the rod is connected to copper plate which is buried deep into the ground, and when a negatively charged cloud is passing above the building, it induces a positive charge on the spike. Since the induced charge density on thin sharp spike is large, it results in a corona discharge. This positive charge ionizes the air surrounding, which in turn neutralizes the negative charge in the cloud. The negative charge pushed to the spike passes through the copper rod and that will be safely diverted to the earth. The lightning arrestor does not stop the lightning, but it will divert the lightning to the ground safely. And another device which uses the principle of action at points. That is a Van de Graaff generator. So this machine was designed by Robert Van de Graaff, and that will produce a large amount of electrostatic potential difference at several million volts. This Van de Graaff generator works on the principle of electrostatic induction and action at points. There is a large hollow spherical conductor which is fixed on the insulating stand as shown in this diagram. A pulley B is mounted at the center of the hollow sphere and another pulley C is fixed at the bottom. A belt made up of insulating material like silk or rubber runs over both the pulleys. The pulley C is driven continuously by the electric motor, and two comb-shaped metallic conductors E and D are fixed near the pulleys. Comb D is maintained at a positive potential of 10 to 4 volt by a power supply. The upper comb E is connected to the inner side of the hollow metal sphere. Due to high electric field near comb D, air between the belt and comb D gets ionized by the action of points. Positive charges are pushed towards the belt and negative charges are attracted towards the comb D. Positive charges stick to the belt and move up. When the positive charges on the belt reach the point near the comb E acquires negative charge and the sphere acquires positive charge due to electrostatic induction. As a result, the positive charges are pushed away from the comb E and they reach the outer surface of the sphere. Since the sphere is a conductor, the positive charges are distributed uniformly, like this. On the outer surface of the hollow sphere. At the same time, the negative charges nullify the positive charges in the belt due to coronal discharge before it passes over the pulley. When the belt descends, it has almost no net charge. At the bottom, it again gains a large positive charge, and the belt goes up and delivers the positive charges to the outer surface of the sphere. This process will be continued until the outer surface produces the potential difference of R of 10 power 7 volts, which is the limiting value. And we cannot store charges beyond this limit since the extra charge starts leaking to the surroundings due to ionization of air. The leakage of charges can be reduced by enclosing the machine in a gas-filled steel chamber at very high pressure. The high voltage produced in this Van de Graaff generator is used to accelerate positive ions like protons and deuterons for nuclear disintegrations and other applications.